Today we're going to be looking at velocity as the integral of acceleration with respect to time. So previously we know that the acceleration is found by the derivative of the velocity with respect to time. So obviously the opposite of that gives us velocity is the integral of acceleration with respect to time. It's the same idea as what we looked at with displacement and velocity. Now, the thing to bear in mind with acceleration, the object is not necessarily at rest at time equals 0. So we need to consider the constant of integration. Previously, when we were looking at displacement when we had displacement as an integral of velocity at t equals 0, the constant s equals 0. But that's not the case with acceleration. The object could be travelling already at a constant speed with acceleration 0 and then start accelerating. And in that situation you would need to be working out the constant of acceleration. So let's look at some examples and see how this works in practice. So a particle moves in a straight line so that its acceleration a at time t is given by a equals 8 minus 4t. It starts with velocity 2 meters per second. Find an expression for velocity. So we've got a equals 8 minus 4t, and the velocity is going to be the integral of 8 minus 4t dt. So we're going to integrate this, so that's going to give us 8t minus 4t squared over 2, and then we have our constant of integration. So that will be 8t minus 2t squared plus c. Now, at t equals 0, v equals 2, so 2 equals 0 minus 0 plus c, so c equals 2. Therefore, the expression for velocity is going to be 8t minus 2t squared plus 2. Let's look at another example. A particle moves in a straight line so that its acceleration a per second squared at time t is given by a equals 12 minus 4t minus 0.6t squared. The particle comes to rest after 5 seconds. Find the initial velocity of the particle and find the displacement after 2 seconds. So firstly, we're going to look at the velocity. So we've been given the acceleration and we want to find the initial velocity. So we're going to integrate this to get the expression for the velocity. So that's going to give us 12t minus, that's going to be 4 divided by 2 is 2t squared minus 0.6 divided by 3 is going to give us 0.2 t cubed plus c at t equals 5, v equals 0. So 0 is 12 times 5 minus 2 times 5 squared minus 0.2 times 5 cubed plus c. So c is going to work out at being 15. So our expression for our velocity is 12t minus 2t squared minus 0.2 t cubed plus 15, and we want to find the initial velocity. So at t equals 0, v is going to be, so it's going to be 0 minus 0 minus 0 plus 15. So it's going to be 15 meters per second. And the second part of the problem is find the displacement after v seconds. So the displacement is the integral of the velocity. So we're going to integrate this expression again. So that's going to give us, now this is going to be 12 and that's going to divide by 2 is going to be 6t squared minus 2/3 t cubed minus 0.05 t to the power 4 plus 15 t. So now at the beginning of the motion, the displacement will be 0, so there's no constant of integration. And at t equals 2, s will be, slot all that in and calculate it out, you'll get 47.9 meters. So I hope that helps.